In this video, we're going back to ions, and we'll be discussing their charges, more formally known as oxidation number. Remember that an atom is an electrically neutral particle composed of electrons, neutrons, and protons. So what does this mean? It means that a neutral atom has a charge of 0. But an ion has a charge, right? An ion is an atom that gained or lost electrons, and we know these ions as cations or anions. A cation is a positively charged atom that lost electrons, whereas an anion is a negatively charged atom that has gained electrons. Previously, we talked about a neutral atom and we put a charge to it and changed it into an ion. So for example, calcium atom. We have the symbol Ca. When a calcium atom loses 2 electrons, it has a charge of +2, and so when you put the two together to make an ion, it's Ca2+. A chlorine atom is Cl. It gains an electron, -1. So symbol for the chlorine ion is Cl1-. Now, in today's video, this is what we're going to talk about. You are going to learn how many electrons an atom will gain or lose, and what the charge is for a specific element. Now, the more formal name for charge is oxidation number. And this indicates how many valence electrons the atom will lose or gain. Remember that a valence electron means the outermost electrons, and those are the ones that will be lost, or an atom will be gaining those valence electrons. So the metals tend to lose electrons because metals have a low number of valence electrons. And that's why metals are known as the cations. So if you take a look at the picture here, the lithium atom has 1 valence electron, but when it becomes an ion, that 1 electron goes away, and you'll notice that it doesn't have that 1 valence electron anymore. But now how many does it have? It instead has 2 total valence electrons. The nonmetals tend to gain electrons and therefore are known as anions. So for nonmetals, because they already have a lot of valence electrons, they want to gain the electrons. So a fluorine atom already has 7 valence electrons. So how many does it want to gain? It actually just wants to gain 1 more. So as an ion, it now has 8 total valence electrons. So how did I know that a lithium atom will only lose 1 and a fluorine atom will gain 1? Because remember what we said previously when we talked about valence electrons. All atoms want 8 electrons. So they will gain or lose the electrons to get to 8. Now, of course, the exception are the smaller atoms. So like hydrogen, helium, lithium, beryllium, they want a total of 2 valence electrons. But other than that, all the other atoms want 8 valence electrons. Why? Because of stability. So let's take a look at these examples. Beryllium, magnesium, calcium, fluorine, chlorine, and bromine. Take a look at your periodic table and find where all of these elements are. Did you find them? What group number are they in? How many total valence electrons do they have? Beryllium has 2 valence electrons. So, will it gain or lose electrons? Well, beryllium, is that a metal or a nonmetal? It's a metal. So remember what I said? Will metals gain or lose electrons? Metals tend to lose the electrons. How many electrons will it lose? Well, it's going to lose all of them. So it's going to lose 2 electrons. So what does that make the oxidation number? Remember, oxidation number means charge. That means that the oxidation number is +2, because plus meaning lost, 2 because it lost 2 electrons. What about magnesium? How many valence electrons does it have? It also has 2. Will it gain or lose electrons? It will lose. Why? Because magnesium is a metal. And how many will it lose? It will lose all 2. So the oxidation number here is +2. What about calcium? Calcium also has 2 valence electrons. It will also lose 2 electrons because it is a metal and it wants to lose all of it. And so again, the oxidation number is +2. What about fluorine? Fluorine has 7 valence electrons because it's in group 17. Will it gain or lose electrons? Fluorine is a nonmetal, right? And nonmetals tend to gain. So fluorine will gain how many electrons? Well, remember what I said? How many total electrons does any atom want? It wants 8. So it already has 7. How many more does it want? It wants 1 electron. So what's the oxidation number? It's -1. Minus because it's gaining an electron. What about chlorine? Chlorine also has 7. So it will gain 1 electron for an oxidation number of -1. Bromine, same thing. It has 7 valence electrons. It gains 1 electron for an oxidation number of -1. Now, what's the pattern here? What do you notice? That if it's in the same group and it has the same number of valence electrons, it's going to do the same thing, right? It's going to have the same oxidation number. So let's take a look and label our blank periodic table. All the elements in group 1 will have an oxidation number of +1. All the elements in group 2, +2. Let's skip to group 13. Group 13, +3. And then over to our nonmetals, -1, -2, -3. Now notice with our nonmetals, I highlighted the particular elements that you had to know. But why does this stop here? Because underneath them, those are metalloids, right? And I'm only interested in the nonmetals right now, since it's only our nonmetals that have these particular charges. So now let's talk about our transition metals. I always talk about our transition metals last because, again, they are unique. They like to break the rules and things like that. So in group 3, we have +3. And then we'll talk about the transition metals, the oxidation numbers for these transition metals at a later time. But what you have to know today are these charges here, where zinc is +2, cadmium is +2, and silver is +1. Now, all of our noble gases will have a charge or oxidation number of 0. Why? Because they already have a full octet, right? So take some time to label your periodic tables, whether you're labeling your big master copy periodic table or the notes. Make sure you have these down. These are oxidation numbers that you will have to know by heart. And these oxidation numbers we will be using next unit, so please make sure you memorize these now. So let's take a look at some practice problems. Let's write the electron configuration for a neutral oxygen atom. So this is, we didn't do anything to it. Let's just write the configuration as it is. So oxygen is number 8. And the electron configuration is 1s2, 2s2, 2p4. Well, how does that change for an oxygen ion? So the fact that this now says ion means that I need to refer to my oxidation number chart, the one that you guys just labeled. And this time, instead of me telling you how many electrons it loses or gains, you need to know the oxidation numbers when you see this word ion. Okay? So what do? You find oxygen on the periodic table, you cross-check it with what you just wrote on your own notes. What's the charge or what's the oxidation number for the oxygen ion? Yeah, it's -2, right? And so what does that mean? If originally in a neutral oxygen atom we have 1s2, 2s2, 2p4, what does the 2 minus mean? It means that it gains an electron. Oh, I'm sorry, it means that it gains 2 electrons in this case. So instead of writing 1s2, 2s2, 2p4, how does that change? It changes to 2p6, right? It gains 2 more, so that I have to add 2 to that. What about the lithium ion? So again, look up lithium on your periodic table. Check it with what you just wrote on your notes. You should see that lithium ion is lithium 1 plus. Okay? So, how do I write this one? If originally lithium is 1s2, 2s1, that 1 plus means that 1 electron goes away. So really it's 1s2. So the lithium ion has the same electron configuration and the same amount of electrons as what element? If you said helium, that is correct. An atom has the following electron configuration. How many electrons will this atom lose in order to have a noble gas configuration? Meaning the configuration that's the same as a noble gas. Well, where would a noble gas stop? It would stop right here, right? At a 3p6. All the noble gases stop at p6. And so really, it wants to lose 2 electrons. Remember, that's the goal. It wants to either gain or lose until it can get to the same position as a noble gas, which is 8 electrons, or if we're talking about the smaller atoms, then that would be 2 electrons.